right, so we'll pick it up where we left off last time with this demonstration of encapsulation by defining a structure for books. Remember that encapsulation consists of three things: the grouping of pieces of data that act together, or that form one logical unit. Also, the protection of that data and the grouping of functionality that acts on that data. But remember that C really only provides for number one here. The grouping of pieces of data that form one logical unit. The way that we did that was through the use of a series of structures over here, right? So first of all, we identified the things that make up a book, and so we created a type def structure, book, and we started out by putting everything into that one structure. But then we quickly realized, well, wait a second, an author is not really a book, and it's two pieces of data. So that was screaming out to us to use another structure where we could add other things like, say, date of birth. And then the date, of course, was other pieces of data all strung together. So we've got we've now separated everything out into logical units, and then they're composed of each other, right? And that's our first observation here, that a structure is composed of multiple pieces of data. In fact, that's a keyword that's used in object-oriented programming. That's called composition, where one object owns another object, or there's one box within a box within a box, right? That visualization that we looked at. We also observed that order matters. Order of declaration matters, right? If one structure uses another, it must be declared first, right? So order matters. The variables inside of a structure are called member variables. So for example, over here in our structure for book, it has 4 member variables: title, author, release date, and rating, right? Over here in the author structure, it has 3 member variables. It's a member of that structure. And so anytime we refer to a member variable, we're talking about the variables inside that structure. You can, no, I don't want that. When you create an actual variable of that type, it is known as an instance, right? So it's an instance variable. You're creating an instance of a book. This instance, this book, that book, that book, right? So over here in your main, where we left off with the demo, we created an instance of a book, right? B is an instance of the book structure, right? In fact, I'm going to go ahead and cut and paste that and put it down as in our observations here, right? So if you create a book B, right, then B is an instance of that structure, right? To access member variables of a regular old structure, you use what did we call that thing again? This thing right here, other than a period? The official name was the direct component selection operator, but we shorthanded that to the dot operator, right? You can use the dot operator. Oops. The dot. There we go. So for example, if I have book B, I can go b.title, right, and do whatever I need to do with it, right? The dot operator allows you to select a member variable out of it, right? Style notes, right? Names of structures should be upper camel cased, right? Member variables should be, just like any other variable, should be lower camel cased, right? Of course, you can have variations on that. You can use underscore casing if you want. You just have to be consistent. Don't make one structure have lower camel casing and another structure have a lower underscore casing or anything like that, okay? You end the definition with a semicolon, right? Member variables, this isn't necessarily style, this is actual syntax, but member variables are ended with a semicolon, right? So those are the syntax issues that you have to remember, right? So over here in the book header file here, again, we end it with a semicolon, and each one of these member variables is ended with a semicolon, semicolon, semicolon. That's in contrast to an enumerated type, typedef enum, where it was a list. This is the first item, comma, second item, comma, third item, comma. Okay? These are actual variable declarations, so you end them like variable declarations. Okay? So let's go ahead and continue with this demonstration where we left off. We were trying to create a book, right? We created a book, and then we realized, well, wait a second, the title, we need to copy that over. We need to do a deep copy of that. The author's first name, we need to do that. The author's last name, we're going to have to do a lot of this stuff, right? Do we want to cut and paste these dozen or so lines of code anytime we want to create a new book instance? Probably not. We want to take that and put it once in one place and then reuse that over and over again. That's going to be, I'll come back and cut and paste it later, right? That's going to be our factory function here, okay? That's where we left off. We said that we'll take the raw materials, like the title, the first name, last name, release date, and year. We'll take the raw materials and manufacture in a factory an instance of a book for you. Now, we also had a return type here of a book star. In other words, I'm going to create that book over there, and I'm going to tell you about it. It's over there. What am I doing? I am pointing to it. Right? If you are going to create a book like that, you need to use malloc. Okay? How do we go about doing that? Well, first of all, what if I didn't use malloc? Could I return something like that? You could, but it doesn't match the pointer variable. Okay, well, how do we take a regular old variable like book and change it into a pointer variable like book star? We could do something like that, and that's even more wrong, right? That's wrong because what happens to that book? Where is that book allocated? It's allocated on the stack. What happens to that stack frame when you return from your function? Popped off the stack and it's gone. This book is destroyed at that point. We don't want to do that, right? So that would be wrong as well. If I want to return dynamically allocated memory, I need to dynamically allocate it by calling malloc, right? So if you want a book star, I'll just call it B, right? Then you need to make a call to malloc, just like you would if you were creating a new integer array or a new string or something like that. Return B. All right. Well, if I were creating a new integer array, what would I cast it to? Int star. If I were creating a new double array, what would I cast it to? Double star. What if I were creating a new string? I would cast it to a char star. None of those situations apply here. Instead, what do I have? I have a book. So how should I cast it? Book star. Right? See, the thing about structures is that once you've defined them, you can pretty much treat them like any other variable that you're already familiar with. Right? If you go int x is equal to 42, that's built into the language. The compiler knows how to take care of that. The compiler doesn't know how to take care of a book, though. But once you've defined it, right, then it can do all the other the tricks that you're already familiar with. It knows how to do a pointer to it. Right? It also knows how to do a size of it. Right? So how many bytes are in a book? Right? Well, how many bytes are in an integer? Size of int. Right? How many bytes are in a double? Size of double. How many bytes are in a book? Book. Exactly. How many of them do you want? Just one. Right? If you want to leave it like that, go ahead to emphasize that this is not an array. This is one book that I'm pointing to. Right? This book over here. Right? If you want to, you can go ahead and leave it off because x times 1 is equal to x. So I'm creating that book. Now let's go ahead and fill in all the rest of it, right? Everything over here. For example, I want to copy over the title, I want to copy over the rating, I want to copy over everything else. Okay? Oops. Oh. I'm in the wrong file. Okay, I'm going to cut and paste that, and then I'm going to cut and paste this and take it over to our actual source file over here. There we go. And then what should be in my header file? Only the prototype. There. Okay. Fixed. All right, continue working on what we were doing here. All right, so the book title, b.title is equal to whatever title I was given, string copy into title, same thing with the author, same thing with the rating here. Right? Well, first of all, you're going to be doing this over and over and over again. You might as well just get used to doing what? Cutting and pasting utility functions like this. Right? Hopefully you're finding that out on your hack this week. Right? That protein sequencing exercise might seem daunting until you realize that you've done it all already. Right? That program should be literally no more lines than 7 lines of code, and that's it, period. If you are writing a program that is more than 7 lines of code, you are doing something wrong. Right? Why? How do you load up the DNA sequence from a file? Didn't you write that in the first part of the hack? File get contents. Right? You have to remove all possible white space. How do you do that? You did it in your last hack. Remove char. Right? You need to convert all, thionine to uracil. In other words, replace all characters of T with U. You did that in your last hack. Right? Replace char. Then you need to split it up into trigrams, codons. Every three characters. That sounds familiar too. Right. When did you do that? Length split. Right? So there's your 3 or 4 lines of code. Then you write a loop, and all you need to do is call our function, and you are done. Right? So assuming that everything else is worked up to this point, right? Maybe you definitely need to go back and fix it because you're going to want to use it, right? And we'll release those later today, by the way. But otherwise, that protein sequencing should be literally no more lines than 7 lines of code, right? Because you've done it already. All right. So if you've written deep string copy once, never write that again. Copy paste, right? Reuse that function, and that's what I'm going to do here. Deep string copy. B.title is equal to deep string copy of title. There we go. Much cleaner, right? Now let's go ahead and try to compile this. CSCE 155E. All right, there we go. GCC C books, or book.c, excuse me. All right. Now the compiler is going to complain about this. Hopefully not too many complaints. All right, so a couple of complaints here that are irrelevant. Now that I'm using the string library, what should I do? Include the string library. I probably should also include the standard library, just in case, right? I probably should be doing, what's the very first thing I should have done that I'll leave you as an exercise to do? Error handling. All right, there we go. And there, oops, darn it. Hunt for the missing, oh yes, okay, there we go. That's the error that I wanted, right? It's having a problem with that dot operator on this line right here, right? And the reason is, tell me, what's the variable type of B? What is it? A book pointer, right? You can use the dot operator if you've got a regular old structure. We don't have a regular old structure. What do we have? A pointer to a structure. So how do I take a book star, a pointer, and turn it into a regular old book so that I can use the dot operator? I need to dereference it, right? Dereferencing it makes it into a regular old variable. Then you can use the direct component selection operator, the dot operator. Except that you pull out your big book of PEMDAS, right? And you look at these two operators, dereferencing operator and this dot operator. And they're out of order. What you end up having to do is putting parentheses around the dereferencing operator in order to do the dot operator. It's just like before when we were playing around with pass by reference variables and I warned you about doing something like this. That doesn't work. Why? Because the plus plus happens before the dereference. So you end up pointing to memory location 1, 2, 3, 4. Then you increment that. Now you're pointing to memory location 1, 2, 3, 4, 5, right? It's wrong. So what you end up having to do is parentheses, dereference, then you can use the dot operator. And the compiler will be perfectly happy about this, but I'm not going to be happy about it because I have to write a lot of code, right? There, well, okay. I'll take that out, right? There we go. That's not real code. That was just me whiteboarding something, right? Now it's fine, right? Oops. Oh, title is equal to, sorry. There we go. Now it's fine, all right? I don't like having to remember that, right? I don't like having to pull out my big book of PEMDAS and remember, oops, the dereferencing operator has a lower order of precedence than the dot operator. The C folks, likewise, didn't want to have to remember that. So they introduced some syntactic sugar here. If you've got a pointer to a structure, you can use the blank operator. What would you call that operator there? That's, by the way, it's the indirect component selection operator, but it looks like an arrow. It's the arrow operator. Right? Arrow operator, arrow operator, arrow operator, because we have a pointer to that structure. Right? Now I can fill in the rest of the blanks, right? So let's see, the author, right? Their first name should be a deep copy of the author first name. Fill in the blank though. Right? Is the author a regular old structure or is it a pointer to a structure? Let's go back to our header file here. Right? So within that structure, a book structure, we have an author. Is that a regular old structure or is it a pointer to a structure? Is it a pointer? I don't see a star anywhere. It's a regular old structure. This would be a pointer to a structure. Right? So consequently, we use the dot operator here. Right? So a combination of these two things. The author's last name, we'll set that equal to the author last name. Right? And granted, this is a lot of boilerplate garbage, right? Release year, or what was it? Release date. Release date, there we go. Dot year is equal to release year. This is a lot of boilerplate stuff of just taking values in a collection of variables and then putting them into a bunch of other variables. Yes, it is a lot of boilerplate. That's why we put it into a function, so we never have to do that thing again. Right? Now that we've got that function, let's use it over here in demo. So I will want a pointer to a book. And I can hand off all this raw data, all this raw materials over to my factory function, and it will build it for me. What do I call it? Create book. And title, author, first name, last name, was it? Last name, release year, and rating. There. Done. It's all contained inside of that one function. I don't need to worry about that anymore. Okay? I do need to worry about how to print it, though. So as one more part of this before we go back and make some more observations, I don't like to have 1, 2, 3, 4, 5, 6 lines of code here if I can help it, right? Granted, I've not copy pasted this over and over again, but I am calling it over and over again in this function. That should be screaming out to you to do what? Put it into a function. Right? So something like, say, print book. Okay. A void function, sure. Right? So prints the given book to the standard output. The given instance of a book to the standard output. Okay. So what's my input to this function going to be? Book B. I can give it a regular old book, but that's passing something by value, right? Versus passing something by reference. One of them, now it's not that big of a deal because a book is only maybe 56 bytes or something like this, something like that. You're only going to end up copying 56 bytes onto the program stack, right? Not that big of a deal, but we can do better. Right? Instead of passing the entire book, just so that you can print it, what could I pass instead? What's the opposite of passing by value? Pass by reference, meaning that I would pass a pointer to it instead. Right? Okay. And by the way, am I going to be making changes to that book? Am I going to change the author or the title or anything? No, I'm just going to print it to the standard output, right? So how can I make that promise that I'm not going to be making changes to your data? Const. Right? Again, once you've defined a structure, it's like any other variable in C, right? Now C knows about it. It can make it const. It can have pointers to it. You can use size of to determine how many bytes it takes, et cetera, et cetera. Right? Okay. Const. We'll put it down here. Right, there we go. So I want to print this to the standard output. I could cut and paste this formatting over here, but I don't want to do that formatting. What I want to do is I want to do more tabular formatting. So if I were to look at all of these books, say in .csv file, right, that's not intended for human consumption. I would much rather it look something like this. CSV to HTML table. Something like this. Let me go ahead and grab all this data and put it over, convert CSV to HTML. There we go. And I want to CSV to HTML table. There we go. I want it to look something like that, right? That's intended for human consumption, where you've got, say, one column, rows and columns, and they're nicely aligned, et cetera, et cetera. Now, the first one is not the header there, but you get the idea, right? I want it to look something like that when I print it out. So let's do that instead. Printf. I'll print out the title, right? Maybe I'll even align it so that it's at least 30 characters and justified to the left. And then I'll print out the author's last name, comma, first name, right? Maybe the year, right? %D, with a rating at the end, %F, and the line. All right. How do I get access to the book's title? Right. Is this going to be the dot operator, or is this going to be the arrow operator? Which one? The arrow operator. Why? Because book B is a pointer to a structure. Right, there we go. B's authors dot last name. Right. B's authors dot first name. Right. Then that formatting last name first name. Right. And B's release date dot year. Right. And B's rating. There we go. And then return. There we go. Make sure that this works, or printf. What am I doing now? I'm doing standard input output, so I need the standard input output library. Probably should have just done that immediately, right? But there you go. Now over here in our demo, let's not print that out anymore. Let's just go ahead and print book B. Much, much cleaner code, right? Instead of 6 lines, I've taken those lines and put them into a function, and I'm just doing that one line of code that says what it actually does. GCC book.o and demo.c. Run it, and we'll see that this is in a more tabular form now, right? There's Harry Potter and the Deathly Hallows, Name of the Wind, Rothfuss Patrick, 2007, with its rating right there. Now, I could go back in and tweak this so that it's exactly right. I could go back in and make it output HTML code instead, right, if I knew HTML. Right? I could do a lot of things there. I'll leave it as it is for now, right, because that's not going to be my focus. What my focus is going to be is, well, wait a second. Sometimes you might want to actually print to a file. Sometimes you might want to print to a socket because you're trying to communicate this data over the network. Sometimes you're going to want to print to X, Y, and Z. So, is there a way that we can generalize this function so that we could use it to print not just to the standard output, printf, but to file? To a what would I have to do? I would have to cut and paste this entire thing and change it to, what do we use to print to a file? fprintf. Right? Copy, pasta, copy, pasta, copy, pasta, repeated code. Good, bad, what? Bad, right? So, let's think of another function that we could do. What if I had a function that said book to string, right? And it returned a string representation of that book? Right? Same thing here. I'm not going to be making changes to it, and I want to pass it by reference so that it's efficient. Again, what this does is it returns a tabular, human readable format of the given book as a string. There we go. All right, let's write that instead. So I'll replace this. There. All right. So what should that look like? We're not going to print to a file. We're not even going to print this to the standard output. What are we going to do? I want to return this formatted string right here. All right. How can we print to a string? Do you remember? You could use scanf, but scanf is for input, printing is for output, so sprintf or sprintf. Right? You are printing to a string. Well, I need a string first of all, right? Char, I don't know, s. We'll make it big enough, 1,000. Right? And I'll print to that string, and I'll try to return that string. Let's find out if this works. So GCC, look, nope. String, I'm returning an address of a local variable, right? Let's think about this. What type of array is that? If I said the two keywords, is it dynamic or is it static? It's static because I didn't call malloc. Static arrays are created on the stack. What happens when the function returns to that stack frame? It's destroyed. It's popped off and destroyed. So what happens to that variable? It's gone. I can't return it. All right. If I'm going to do something like this, I need a dynamically allocated string. Char s is equal to char star malloc size of char times how many bytes do you want? How many characters do you want? Well, if you want to print the title, strlen of title. If you want to print the last name, strlen of the last name, strlen, 4 years for the year, four characters for the year, 7, 8 characters for the rating, something like that. Also the formatting, right? At least 30 characters, the space, the comma, the space. Does anybody really want to go through and count all that stuff up? Nope, because you're not going to get it right anyway. Right? So what I want to do is have a combination of static and dynamic strings. Do you remember when we wrote the remove all white space function when we were looking at strings in class maybe a week or two ago? What did we do? We said, well, okay, this is kind of difficult. I don't want to shift things down and remove that one particular space. What I'll do is I'll create another string that's big enough as a temporary workspace, copy things over, and then once I'm done with that, I'll take that result and put it where it needs to be and then clean up after myself. I'm going to do the same thing here. Char temp. It's a temporary string that is big enough to hold whatever I want. And then I'm going to print formatted into that temp string. Once it's taken care of, once it's exactly the size that I want, now I do know exactly how big it is. strlen of temp plus 1. Right. Why plus 1 again? Null terminating character, exactly. And then strcpy into s of temp. Gee, I could take that 2 lines of code and make it into 1 line of code, I bet. Right, there we go. All right. I need to make sure that I clean up after myself. Right. Should I free temp? No. In fact, the compiler is going to warn me about that. Right. You called free on an unallocated object. Unallocated means that you didn't call malloc on this thing. Right. What's going to happen? Can you delete your own stack space? Well, you can, and then your program is going to segfault out with you just smashed your own stack with a hammer, right? That's a stack smashing event, right? So this one is wrong. Wrong. You cannot free your own stack, right? Okay, fine. Free S? No, why? Yeah, you're returning S. Don't free it. Don't destroy it. Right. Dot, dot, dot. All right. So both of those would be wrong, and I'm going to leave them in there as notes to yourself to not do that. Right? Otherwise, it should be good as far as compiling goes. Now let's rethink this up here. I've got a lot of repeated code. Repeated code, repeated code. Let's not do that. Right? I've got a function that returns a string representation of that book. Use it. Right? Book to string of B. Right? Now to print it out to the standard output, it's just printf %s and the line s. And you're done. Where are you? Right. Say again? Because I'm using proper prototypes, it won't matter, right? So order doesn't matter because of prototypes. The order matters does matter with respect to structure declarations. There are alternative syntaxes that you can get around that, but I'm not going to show that because I don't want to. I'm only going to show you one way instead of the 3 or 4 different ways that you can do it. Right? Think about this though. Is this dynamically allocated or not? It is. Yeah, what happens? Free s. Why? You created it right here, or more to the point, book to string created it, gave it back to you. Now print book is now responsible for this memory. It prints it out, it's done with it, right? Oops, whoa, I don't know what that is, but we are done with s, right? Free it. If we didn't, we'd have a memory leak. Okay? Now that's much better. Excellent. And did we have to change our code over here at all? Nope. It was all opaque. Right? Excellent. Let's go ahead and bring all of this stuff together now. And run it again. Right? Works perfectly fine. Let's ask Valgrind. There will be memory leaks, by the way. There's one error. The one error here is a memory leak. We lost 1,280 bytes. I'll let you guess. How many books did we create? 20. 1,280 divided by 20 is 64. Each one is 64 bytes. All right? So I'm creating a book right here. I'm printing it out, and I'm essentially done with it. So what should I do once I'm done with it? What did I do with the string once I was done with it? I freed it up. Free B. Right. Okay. Maybe. Let's think about that for a moment, though. What is a book? A book is those 4 things. All right? Did we free up the memory for that string? Nope, we just freed up the pointer for that string. We freed this up, we freed that up, we freed that up, but we didn't free everything else up. It's way more complicated, right? If you are going to create, if you're going to create a bunch of dynamically allocated stuff using deep copy string, you need to make sure and you go through and you free all of that up. So what would it look like? Void free book. Right? And by the way, can I go const book B? No. Why? Am I going to be making changes to it? Yeah, I'm going to be deleting it. I'm going to be removing it, freeing it up. All right? So what does it look like? What's the first thing that I should free up? The title. All right? So, actually, could I free B right now? Yeah, but then can I free B's title? Nope, because I've already destroyed it, right? It's gone. So order matters. Right? Free the title. Is there anything else I should free? What about B's author's first name? Yep. B's author's last name. Anything that I ended up dynamically allocating when I created this thing, title, first name, last name, that all needs to be cleaned up. Then I can free the book. Now let's see if that solved that problem. GCC. Oh, I didn't call it, did I? free, not B, but free book, B. There we go. GCC book, GCC everything together. Now let's run first of all, let's make sure that we didn't break anything. And then let's run it through valgrind to see if we've cleaned up all of our memory. Beautiful. Right? Perfection. 0 errors, 0 memory lost. Right? All right. So let's continue making some observations here. Using structures. Right? Oops. So once you've defined them, once defined, you can create instances of a structure or pointers to instances of structures. Right? For example, structures book B would be a regular old structure. Book star B would be a pointer to a structure. To access member variables of a pointer to a structure, use the arrow operator. Right, so B arrow rating, whatever you're trying to access. Okay. Let's see. You can or should define utility functions. For example, you can define a factory function to create new instances. Right. You can define two string functions to print or convert data to a human readable format. Right. You can define destructor. So destroy, right? Destructor. Sometimes factory functions are referred to as constructors. You're constructing an object, right? The opposite would be a destructor. You're deconstructing the object. You're freeing it up, right? You can define destructor functions to free up memory properly. Right? You can also define initialization versions of a function. Right? So suppose that an instance already exists. Right? You simply need to allocate or to assign or allocate its values. Right? So that's the last thing we'll do today, and then we'll pick it up on Monday. What I mean by that is, over here, CreateBook was responsible for creating the book entirely, right? It called malloc, it initialized it. What if you just had a regular old book, like say book B, so you already have it allocated. You just want to set its author's first name, author's last name, its title, etc., etc. That would mean that you have a void function that takes a book, right? I don't know what we'll call this just yet, but it takes a book star B, and everything else needed to initialize that book. Right? Come on, there you go. All right. I'll fix the rest of the white space here magically in a second. Right? What I would like to call this is init book. Right? Init, short for initialization. The book already exists. I'm telling you, I created it, but I'm going to give it off to this function along with the rest of the raw materials so that function can take care of all the details for me. Right? It's like following a recipe. You gather all the materials and then you hand it off to somebody else to mix up and actually cook the meal. Right? It's an initialization. So let's go ahead and fix the white spacing here first so that it looks nice. What utility should I use to fix the white spacing? A style. Right? Artistic style. Book.h. Right? Close this, reopen it. Ooh, nice. Everything's now nicely aligned. Okay. Note here, why did I do all this vertical alignment again? I could have put it all in one line. White space doesn't matter. But what would I be doing then? Scrolling back and forth, scrolling back and forth. I want to read it like a book, top to bottom. I don't want to have to turn 10 pages over to see the rest of it, right? All right, what would this look like? It would look very much like this, right? Let's write it and see what code translates over as just a simple copy paste. I'm going to go ahead and take all of this and put it right here. Now the book already exists, so should I be creating it? No. Right. You were given it as part of the input, B. We'll go ahead and copy the title. We'll copy the first name, copy the last name, copy the year, copy the rating. It's a void function, so we don't return anything. Right? So it's a little bit of a difference, right? One of them completely creates the book from scratch. One of them assumes that the book already exists and then initializes all of its values. A creator, a constructor, a factory function versus an initializer, an initialize function. Except that I see a lot of repeated code, repeated code, repeated code. Right? Those are called code smells. Right? I think we've talked about that term before. Right? It smells like our house smelled the other day, so we were like, what is this? Right? And well, we needed to take out the trash, right? Because we had chicken in it or something, right? Other things might smell bad, but it's intended, right? I think the example I give usually is lutefisk. I asked last time, has anybody ever had lutefisk before? It stinks. Oh, well, another example would be a durian fruit, right? Have you ever heard of a durian? Is it durian fruit? The fruit that tastes good, but it smells terrible. All right, am I saying that right? Durian? Okay, there you go, right? So code smells aren't necessarily bad things. It's just that you need to take a second look and say, could I improve this? So could I improve this? Should I or should I not be repeating these 5 lines of code here? It seems to me that one of these functions could call the other function. Right? Well, this one already assumes that the book is created, and this one creates the book. So what could I do? Init book, B, and pass everything else off. Title, author first name, author last name. There we go. And release year and rating. Now do I have any repeated code? Nope. I've reduced the number of failure points as well, right? Because if there was a bug in the somewhere in those 5 lines of code, then I've got twice as many bugs because I've repeated that code somewhere. If I've only got 1 copy, then I've only got 1 bug that I need to deal with, right? Because if I had 2 copies with the same bug and I fix the bug here, that doesn't fix the bug here, right? You want to reduce the number of potential failure points, right? You want to make sure that functions are calling other functions, to wit, your current hack, right? That protein sequencing was designed so that you would reuse all the functions that you've made over the last couple of weeks. Right? Again, it should be no more than 7, 8 lines of code or something. Right? All right. Any questions? Then have a good weekend. We'll pick it up there on Monday.